All right. Also talking about this week. So today's the 8th, right? Tomorrow we'll be doing closure, like all together. Like that's what our class time will be. And so if you don't finish it in class, then it'll be homework. But then Thursday, Friday here. Here's my debate. It's like we got to take your next mastery at some point. So the question is, do you want to take it right like this week and just take it as soon as we can, which would make sense and is what I have planned, and then we would just start the next chapter like next week, or I was debating us spending 2 days to make sure closure is really good. And if we're done with closure early on Thursday, we could start the Friday activity, which would be a mega Jenga review game. So that's actually what I have written here. I was looking at the wrong thing. So we haven't done this yet, but the only way review games are able to be played is if you're totally done with your practice work. So your ticket to playing the review game is handing me your practice work. All the rest of the chapter 2 work. So what I'm saying is, if Friday is going to be a review game, it would only be a review game for you if you're totally done with practice and essentially ready to take the test. Then we would take your mastery Monday, Tuesday next week, and that's it. That's the end of the quarter. So how does that sound? Mastery next week? Yeah. As opposed to, some people are like, no, let's just run through and take it down. But we have the days. We could do a review game. It could be fun. Now that does mean I'm going to make the test slightly difficult because we're going to all play a review game together with questions exactly like what are on the test. Okay, so that works. So test Monday, Tuesday. Test Monday, Tuesday. All right, so we are going to do more graph scaling. Do I have any volunteers to read? Because I know you guys are tired of listening to me. Lily, you want to go ahead and read this paragraph?
In this lesson, you will use all that you know about graphs to solve challenging graphing problems. Each of these,
Yeah.
in this lesson, will require you to think hard about what a graph tells you and what the best way to show is. What is to show it. As you work together to solve these problems, think about what makes the task challenging. Focus with your team on how you can get yourself unstuck if your teacher is not immediately available. How does our data fit? And we see it here.
Perfect. Thank you so much. So our first problem here is Andre. Andre has a juice shop, right? Like one of those. I'm trying to think of like Jamba Juice, one of those places. So he's invented a new Mathberry Madness smoothie. Yeah, Andre's my dude. So word is getting around, right? They're like, ooh, Mathberry sounds delicious. So he wants a graph showing how many new smoothies have been sold through the first month. So he's gone through the cash register and he has this data in front of you, right? Day 3, we sold this many. Day 4, we sold this many. Day 6. This is like days after he released it. So he wants to graph his data and use it to predict how many Mathberry smoothies he'll sell on day 20, right? Because we have up through day 12. So our task here, Andre's graphed his data. Right? He's got a graph here for us. What we want to do is analyze Andre's graph and write down, right, as we talk with our team, but write down any issues you see with his graph. So I'm going to random card this and be looking for what you have written down, but talk with your group. These points are the points, like, they are this. I know you can't see both at the same time, and actually if I move this, you can. So I move that up, you can see everything at the same time. Your objective is talk with your teammates, figure out what's wrong with his graph, how could we draw an appropriate graph of this, and then do that, right? So I'm putting that there to help kind of block things apart. Talk with your teammates, what's wrong with Andre's graph. I'll even say you don't have to write down the things that are wrong with this graph. Just go ahead and make an appropriate graph. So since all of our values are positive, you don't need to do one of these. You can just do one of these, right? Just a positive coordinate coordinate. So dive in, fix Andre's graph. You can write down the table if you want, or you don't have to.
Between like 3, 4, 6, 9, 10.
What are we doing? Right. So you notice how Sarah's already got her axes started. She's already did not until after that after you decide, okay, I'm done with this one.
You don't have to write it down.
A little on the scale.
It doesn't have the same number.
Days will be our X's and smoothies will be Y. That is what you have to match from his graph. Days will be our X's, smoothies will be our Y.
Literally just pop down the points.
Now you just have to make it.
Like just pop down the points. Or like, no, I'm gonna do 3. No, I'm gonna do
What would be another thing? 3? 2? Because it's most of them are even.
I'll go ahead and take volunteers for what is wrong here. Why is his graph broken? Eric?
The reason his graph is wrong is that you kind of have to look at the x-axis because he started out, or what? Yeah, x-axis. Yeah. The way he did it wrong in the x-axis because he started at 3 and then he went to 4 and then skipped a number for 6 and that's a little confusing, right? No,
Why? Can anyone figure out why he did what he did? Like, this is wrong, but I get why he did it. All right, I'll just go across.
He just took the numbers and like put them down on the paper, and neither of them are like a consistent like counting rate.
There's no consistent scale. He said, what are my X values? 3, 4, 6, 9, 10, 12. 3, 4, 6, 9, 10, 12. Yay! No. Good try. Not really. And then the Y's, he did the same thing. So fix this. You and your partners need to decide what scale should we use for the X's that need to go up to 12. And this depends on how big a graph you make on your page, right? And what scale should we use for the Y's that need to go up to about 40. Hey, but remember, what day are we trying to predict up to?
20.
Day 20. So really, your X's should go up to 20. Right? Even though the X's we see only go up to 12, your X's should go up to 20. That's the other problem with this graph. He doesn't go up to 20.
He goes up to 13.
12.
Because like there's another thing.
So I guess what?
2. For the Y, I think we should do something.
Threes. Do 3s for days.
Oh no, but it has to go to 20 for that day thing. Because it's predictable.
Yeah, we could just go. We could just do 7 spots. 7. 7. No,
Up
21.
21. So it's spread across
7. Like, I was 7. So just do make your S 7.
Guys, should y only go to 40? No, because we're already at like 40 at day 12. Probably even more than that. Look at the growth. They just went up by 10 in the past 2 days.
What about 50?
I'm thinking make it go to like 60 or something like that. I'm going to say that I think they're going to start to do really well.
It's good.
So if I go to graph this, I don't know how much space I'm going to have because it all depends on how much you leave for your axes.
What do you like the calligraphic pen?
What's that?
This type of pen is calligraphic or whatever it's called.
It just makes it look nicer. So you use a lot of your page. You probably have as many squares as I do up here. Because when I plug in this size graph paper, so if I go up to here, I can make myself have 15 boxes. What times 15 gets to 60 is what I should be thinking about. Well, that's 4. So each of my boxes here would need to be 4. So 4, 8, 12, 16, 20. Maybe I'm going to start skipping. 28, 36. We can mark the 40 out here.
Wait, how many squares did you have?
I had 15 tall, just because I can. So I can do a scale of 4 and get up to 60. So really, or I can say I'm a scale of 8 every 2 boxes, but each box is worth 4, right? Because then I started jumping by 8s. Now my across, like I said, my screen's wider than it is tall, so your across may not have as many, but my across.
Wait, why did you not?
Why did I not what?
Like, you put, like, all those, like, close together.
Because then as the numbers get bigger, they literally get like bigger to right. So then I just started skipping. It's the same scale. So if I go back and I fill in, this is 24. This is 32. This is all going by 4s. I just didn't want to fill them all in, but now you've made me. Because now it's really tight and looks kind of busy. I just wanted to make it look less busy. I have enough squares. I can go by 1 here. I can go by a scale of 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this is what I like to do better, is just once I've determined the scale, skip to keep it clean. Now we can accurately plot our points. Does anybody want me to come check your scale on your graph or how you have your axes set up? Because I'm going to wait to plot your points. So if you want me to check things, just like as I come by, just make me glance. Yeah, you went by 5 and by 1s. Now be careful. You would actually put the numbers on the lines, not in between. So like you did here, how you put the numbers on the lines, don't on the X, put them in between. So for both you, on the next graph, just change it. You don't have to change it now. But we make the tick marks. We put the numbers on the tick marks and not in between the boxes. And make sure that you're using your graph paper markings. Don't just draw willy-nilly on graph paper. That's the correct. So guys, I think a few of you are doing that we have to nip in the butt right now is our markings, our scale, especially when we determine the scale, has to correspond to the break in between the boxes, the tick mark. So when we determine that we're going to do a scale of 4, or whatever scale you determine, some of you guys did 5, I have to, on the line, say that's 4. And then 8, 12, 16. This line would be 20. Like 4, 8, This line would be 40. This line will be 60. And we could fill in any other values we wanted, but we have to mark those two the ticks in between the boxes. So I get a graph 3, 3, out to 3 on my x, but not up very far. Right, there's 3, 3. If you have not plotted your points, go ahead and do that now. 4, 5, or a little bit above mine. Now remember, if you scaled yours differently, yours will look slightly different. But guys, this is why we use the lines of the graph paper. You have to follow those lines up and across. And you have to be able to follow what line does it correspond with. 610, 40, 12, 920. 38. You gotta get all those points. Now use that ruler to try to draw a line that goes through those points the best way possible. And I don't mean goes through every point. I mean goes through the points the best way possible. So when I gesture things, when we do volume, you will totally understand when I dump a thing from one thing to the next. You can see that enough. I'm big enough because it's pointed here. I don't care about you guys. For the video, that is. You're my only focus right now. I could care less about that thing. But people watching the video at home, all they care about is me, right? They don't know you. Well, they might know you, but like, it's just so they can see my gestures. I didn't used to do that, but then, especially for like ELL students or students where English is harder to like understand as quickly as we speak, to see body language helps, like to see gestures. So I can cheat, but you have a ruler. So when we talk about line of best fit, which is actually what we're doing here, our goal is to put this line somewhere that essentially it has equal points above it and below it. Now, sometimes we say you gotta line up on the 0, 0. Sometimes we don't. But if we line this up on 0, 0, and then try to make a line of best fit, because on day 1, he probably sold 0, right? Now, at first, you just kind of look at the points that you have, but then we're going to extend it out. The first couple days, I kind of follow a lower line. But if I take the lower line, I'm totally missing these points. So if I try to get those points, my other points are really far away. So maybe, just for our sake, we don't put that on 0, 0, and we kind of put it there. Because that has like 2 points under, 3 points over, or actually kind of like 2 points on and 2 points over. So whatever works for your paper, try to draw that line, and we extend it beyond where we actually go so that the line gets to 20. And I didn't even plan this because it's been a year since I've done this. According to my line, at day 20, We follow the line up. This is why we work with the lines of the graph paper. We find that point at day 20 and we follow the line over. That's why we work with the graph paper. Looks like maybe 60. If this behavior stays the same, it looks like it might be 60. Any questions on how we set this up? Zach, I will come right to you. But if you haven't labeled days and like juice, please do that. Was that a hand raise, Zach, or not? Okay. I thought you were raising it. You were just waiting. You what? You did? Okay, what's up?
My graph, nothing. If I do it at
Day 20. Can you get to it?
yeah.
So your numbers aren't on the tick marks. That's your first issue. Yeah, your numbers. Okay, so everyone, we're going to move on to the next problem, but I have now realized I need to be more particular with coming around and checking what we're doing. So we're going to now graph this. Right? The table at the right shows the time it took 5 different students to get to the mall. We're all going to make the same graph. Okay? So first thing, copy this table down. We're going to make distance the x and the time the y, because time will depend on distance. You can't say time doesn't depend on distance. I can't just make myself get home right now, but I can make myself get to that other classroom right now.
No, not right now.
Do it.
I mean, I can pretty darn quickly.
Go. Please.
Oh, there's a finally this year. You.
Oh, I didn't want to put you here.
Oh, it should be me.
I know, I'm going back in just a second. I had to move something so I can put the graph over here. I was going to just say make your own, but I realized we should all practice one all together. But of course my computer is way slow.
You have a virus.
I don't have a virus. My computer doesn't do anything except for school. It just has a whole lot of things on it and a whole lot of things running right now. Alright, so my friends who might be better at counting than me, let's count this out. We got 19 here, so if you want, you could make yours 20 by 20, but I'm probably going to operate on 15 by 15. So make your XY have 15 boxes by 15 boxes. If you go further, that's up to you, but we're all going to together go 15 by 15. So that's 15. And that's 15. Now on the TV, you still have that table. So our x goes from a lowest value of 0.5 to a highest value of 4.1, but if we round, we could say we're working from 0 up to like 5, right? Now, the question is, are we trying to make any predictions? Let's double check what our objective is. Our challenge, the table at the right shows the 5 how it's small and how they travel there. Create a graph, but be prepared to explain how you got your graph and how it's easy to read. We don't need any predictions here, right? We're just trying to make an accurate graph. Does anybody need me to slow down so you get the axes 15 by 15? Because we're going to do every step of this together. It's 15 by 15, because that is what fits on my screen. If we are operating on a 15 by 15 and we only care for this final value to get to 5, right? Because we only need 4.1 really. We'll go ahead and label distance down here. 5, but this is really 15 boxes. Hey, Toby, you with me? Okay, so if you're with me, if we have 15 boxes and we only need to get to 5, how should I scale the x-axis? How many boxes should equal 1, or what should 1 box equal? There's a nice mathy way we can do this. Nikki, you're kind of his partner, so help us all out.
So, an easy way that you can do it is basically kind of divide it 15 by 5, which would get you 3 boxes equals.
Like we said yesterday, if we have a lot of boxes and we don't need to get a very high number, boxes divided by the number, and that tells you we have 3 boxes per 1 number. Right, so every 3 boxes will be 1, 3 boxes more will be 2, 3 boxes more will be 3. By the way, thank you very much, Nikki. 3 boxes more will be 4. I'm going to erase all this. So we want the nice way of using our whole graph, or as much of it as we can, do the amount of boxes divided by the quantity. Now, really, it's the bigger number divided by the smaller number. Is how we can work with it. Because sometimes it's boxes divided by quantity, sometimes it's quantity divided by boxes. It depends on which is bigger and what we can spread out. So that gets to our target of 5. Our y-axis, sorry, this is x, so label that too. Our y-axis goes up to 20. So I can't use a scale of 1, right? Because a scale of 1 would only get me to 15, right? So if I do 20 divided by 15, right? Which this is now the quantity divided by the boxes. This is 4/3. Well, close to 4/3. What if, because that's like what each box should be, right? Because I need my boxes to be more than 1. Make it bigger and easier to work with. Is what if I make each box 1.5? Because 4/3 we know is actually 1.3 repeating, which is gross, right? This math tells us make each box worth 4/3. Guys, I got some people not with me, and I'm worried that on the mastery next week or the review game Friday, scaling graphs is going to be tough for you, because I put the graph on the paper and I tell you pick the appropriate scale. It's not just random graph paper. So we took the number we need to get to, divided it by the amount of boxes, and now we're going to round it up, because we can't round down. We won't get where we need to. If we round up, stop with the jumpy. I don't know why it does that. I'm sorry for those of you bothered by it like me. What are you doing? We're going to make each box worth 1.5. So really, I'm going to start my scale here and label it what? No. 3. I'm just going to go 2 boxes equals 3 to make the numbers that I'm writing easier. Make it easy on yourself, guys. Now I'm going to turn this off. Well, no, I can't turn it off. It's just really hot. That TV produces a lot of heat. So now we've gotten to 15 before we reach our cap of boxes. Now we've gotten where we need to. We've passed 20. And now if you made your graph a 15 by 15, that's the top of your graph. Right, so we wouldn't have actually a line, we would have an arrow. And it should say Y out here somewhere. Now this axis should also be labeled time. We have distance is the X, time is the Y. So now that all of us have matching graphs, I need you to plot those points, which I will show up here again. But we need to plot these X, Y points. So go to 4.1 on the X, then go up to 13 on the Y. please notice, because some of you I came around and I was correcting this, these numbers coordinate with the lines. So if I go up this line, that's 3 all the way up the line. If I go up this line, it's 4 all the way up the line. So I can go in between. What would this be? 4.5, because we know the distance has been evenly divided. Plot all these points, and we are going to make a line of best fit. Highlighters all over the place around this classroom if you want to use them. Your graph should look exactly like mine, except not on a smartboard. 13. So 13 is just over 12, and 4.1 is just over 4. 13 will maybe be a tiny bit higher. But so 1.5 we know would be right in between. 1.7 is probably just about on that line. And then up to 7. Ooh, 3 is nice. 3 and 10, both of those are nice. 9. 2.220. Zero 0.5 and so yeah, with your ruler, as you go to lay your ruler on top of this and try to find your line of best fit. Do I have to tap? Oh, there it is. Wait, Zach, say that louder.
There is no good fit with this outlier.
Zach thinks there is no good fit line. You guys tell me. So if I line up with these, where's my rotate? I lost my rotate. If I try to line up with these points, I can make a pretty darn good line. Right? That almost hits all 3 of them. But then if I try to line up with these, I can also make a pretty good line between just the 2 of them, but there's no real good. Do we just put it in between them or what? So does that accurately show the behavior that we see here? No. So is it more likely that a person had something happen and their time increased? Or is it more likely that a person was able to like teleport and get to work? The time going up, right? So Zach keeps saying from over there, these people must have hit some traffic, or are coming from parts of town that just like it didn't work out well. So our line of best fit would probably still say it's something like this, and these are outliers, right? So if you want to go ahead and note, sometimes we realize those data points don't make sense. They're outliers. Now, if your graph doesn't look like this, please ask yourself what's going on that it doesn't look like that. You might need to come meet with me or something like that. We're going to do one more graph. We will do another 15 by 15. So please go ahead and set up your 15 by 15. And we are working with prices at the Columbus Recreation Center, actually. No joke. CPM probably realized that Columbus is one of the bigger named cities in America. It actually just got voted like one of the best cities in the world, hypothetically, I guess. Well, not hypothetically, like it happened. Because they say we haven't peaked yet. Like the city is still improving. We're still making things better, which we are. So yeah, we're pretty cool.
We kind of can't say that because we're in Worthington, not Columbus.
No, I mean you can access the Columbus Rec Center.
Well, yeah.
If we want to make a graph of this data, we might initially think like, oh, we can break the graph because we have some big numbers. Now, some of us might not be able to see it, so I guess I should probably pull this up for a second. Should we... Sorry, I don't like that just changed that. I lost it. Should we break this graph, or should we just scale it out? Scale it out, I heard somebody say, why? What's our lowest number for the x? 18. What's our highest number? Like almost 120, right? We need this to go really far. Our lowest number over here, 53, highest number, 150. Like, we need that to have a pretty big spread. So we might as well just start at 0, 0 for this. So the x, I'll put this back on the TV. The x values need to go up to like 120. We have 15 boxes. Can anyone think of what choice would be an easy one if we want to get our value out here, somewhere out here, right, up to 120 when we're working with like 15 boxes? Bella? We can, but we can also just mental math reason through this. If I want to get to 120, I could go beyond that, right? That's okay to go beyond. I have 15 boxes. ES. Could I, instead of going to 120, could I go to 150? And then what would I make each box? 15. Because if I do the division, like Bella's saying, 120 divided by 15, this comes out to be like 8 point something, I want to say. It's either 8 point something or 9 point something. It's almost 10. So we would make this x-axis a scale of 10, and then while our prices also really just need to like go up to 150. What could we make the y scale? Also 10. Because if we're using 15 boxes and we want to get to 150, yeah, this actually needs to get to 150. So then we would do 150 divided by the 15. Now, in an odd turn of events, Goldring has released before myself, so I'll go ahead and say we'll wrap with that. We'll probably do this tomorrow, so keep that graphic. Do not lose it. We'll probably pick up right here tomorrow because we're going to spread things out a little bit and do a review game.
Wait, should that camera see me right now?
Who, what?
That camera can see me?
Kind of.
Yeah, turn it off.
Yeah.